Thanks for watching. I'm Brian Dolly from Embelton. We have 95 years of expertise in the treatment of noise and vibration. One area of expertise is HVAC. The key to noise and vibration control here is to isolate the building structure from sources of vibration, such as a pump. As you can see from the table here, the more you deflect an isolator, the lower its natural frequency, therefore achieving better acoustic isolation. Super shear flex are rubber pad isolators. They deflect 2 to 3 millimeters or more if they're layered and can achieve 80 to 90% efficiency at isolating a 4-pole electric motor. If you must fasten the machine down, we can offer rubber sleeves and washers. These prevent the fastener bridging the machine to the building. Super shear flex pad selection. We use the machine weight and the available pad footprint to select the super shear flex pad. We want it to deflect, so we have various grades available to achieve that. A 100 by 100 blue pad will take 350 kilograms, while a red will take 500, green 650 and black 1,000 kilograms. The deflection of the pad results in a natural frequency. If you need a lower frequency to achieve a higher isolation efficiency, we can stack the pads with a layer of aluminium between each pad. See, a single pad is approximately 60% efficient, while a triple pad is approximately 90% efficient while isolating a 4-pole motor. Rubber mounts are ideal for non-critical application. It is limited to how far it can be compressed and has an internal stiffness, so it's not exactly acting like a spring. Up to 90% isolation efficiency is available for a 4-pole motor. Over that, or for large machines, is where we move to springs. Springs don't have a dynamic factor and can deflect a lot more than rubber, so can offer a much higher degree of isolation. But you can see here, deflecting a spring 20 millimeters offers 98% isolation efficiency for that 4-pole electric motor. And that's why we choose springs for HVAC. In critical applications, less vibration passes into the structure. There is an exception though. High-speed chillers may only require rubber pads. Please ask us for further details. Large fans and variable speed fans and pumps. As these start and stop, they go from 0 to full speed. They're regularly running at low speeds below 1440 RPM. Slower speeds require better vibration isolators to remain at the design isolation efficiency. We use the following example. A 10 millimeter deflected spring at 600 RPM is 67% efficient. At 900 RPM, it's 88% efficient. But at full speed, at 1440 RPM, it's 95% efficient. Seismic mounts are regularly required on high-end projects, especially for pumps, chillers, cooling towers, pipes, and air handling units. Embelton have various models of seismic mounts depending on how many kilograms are going on each mount. I'll hand over to Lloyd Costick, our Chief Engineer, to explain adjusting a seismic mount.
Let's install this platform onto 4 mounts. If I give it a nudge, you can see that it doesn't really move and that the steel brackets are supporting the equipment. The equipment is restrained but not isolated. By turning the adjustment feature to load up the springs, we will see the platform lift off its housing. When I've done this for all 4 mounts and I give it another nudge, the platform is now oscillating as if the restraint brackets were not there at all.
Thanks for watching. If you have any questions or require further details, please get in touch.